So last week we have learned experiment number 00, which is show you how to use the lab archives as a lab notebook. You learn how to edit, how to add the table, how to add the picture, and how to add the video in the lab archives. So this week is the actual experiment number 01, Introduction to Lab Procedures. So if you click on this experiment number 1 folder, you're gonna see 2 pages and 1 folder. So you're gonna read the introduction to know the purpose and what you need to do for this lab, and the experiment, which is where you're gonna complete your assignment, your report, and submit it. The last folder, DNU experiment number 2, you don't have to worry about this. DNU mean do not use. So basically you read the introduction and complete the experiment page and submit it. Don't worry about the DNU folder. So the purpose of this lab, you're gonna learn the different names and different pieces of lab equipment we're gonna use in labs. We also learn some common lab procedures we use in lab most of the time, and vocabularies. So make sure at the end of this experiment, you're gonna be able to know the definition of what is reagents, what is the deionized water, minicus, decant, filtration, and filtrate. Make sure you note on these vocabularies and know its definition and how we're gonna use them. You're gonna see them again in the lab quiz. So your lab course have 2 parts. One part is the experiment submission. So each experiment worth 10 points. So after you submit your experiment, you're gonna take the lab quiz, which is worth 20 points. So the lab quiz is based on the experiment we just completed. So lab equipment, this is the materials and the lab station normally in the regular classroom. So when you read this, make sure you know you watch the video at the end of this introduction. This video at the end of this introduction, it tell you what is the name of each chemical equipment we're gonna use in the lab. So in your lab quiz, I'm gonna draw the picture of the equipment, and then you're gonna be able to answer what is it. So for example, I'm gonna show you the picture of this piece, and then you know it's gonna be the beaker. And this is the balance, and for example, this one is the gravity cylinder. So make sure you watch this videos to know the name and the shape of any chemical equipment we use in lab most of the time, and you're gonna be able to recognize this in the lab quiz. Okay, so all of this are introduction. What is the reagents? So make sure you read this before you move to the experiment part. So experiment, which is where you need to edit the text, fill in the answer. The first one, you need to accurate and approximate measure the volume of any liquid. So there are 2 different ways you can measure the volume: accurately, or you can measure it approximately. So if you measure a liquid accurately, you need to use the pipette and the graded cylinder. For approximately, it doesn't have to be that precise. So you can just estimate, eyeball it. It doesn't have to be exact compared to the accurately measurement of liquid. So the next part, you're gonna learn how to filtration or separating a solid from a liquid. So you're gonna read through this description. You're gonna learn how to fold filter paper. So we don't have the filter paper at home. You can use the paper towel to fold it in, look like a cone shape, and then you're gonna use it. You're gonna use the bottled water to cut it. So and make it that use half of the water bottles. Use a funnel to separate the mixture of sand and water. So basically, when you fold the paper towel, it's used as the filtration paper, and then you're gonna put it on the first half of your water bottles, use it as a funnel, and then you're gonna pour your mixtures of sand and water into it. The sand is gonna stay on the paper, and the liquid is gonna drain through the bottles, and then you're gonna separate the solid sand from the liquid water. So read through this, and then you know how to do the separation or filtration, separate the solids from the liquid water. And make sure you add the image of yourself, of your picture, is similar to this, into this part, at part of your report. Okay, so what is the filtrate? Filtrate is, what is it? And make sure you, if you read the introduction, you should know what is the filtrate in this case. And decanting is a technique. So make sure you be able to answer what the difference between decanting and what is the gravity filtration. And you're gonna learn the use of the Bunsen burner. So Bunsen burner is used to heat any chemical we use in lab. So there is a video for you to watch how to use of the Bunsen burner. The Bunsen burner, the way in the video is show you how to adjust the audio flame. So when you adjust the Bunsen burner, make sure the flame is gonna be in this light blue color. If it's yellow, you keep adjusting until you get the correct or the audio flue flame. So there are different parts in the flue flame, and then in the video it show you where is the hottest part, where is the coolest, and where is the moderate hot of the blue cone flame. So after you find out which point is the hottest part, you're gonna fill out the question in here. There are 3 parts: the bottom, the middle, or the tip of the inner cone. You're gonna see the audio flame have 2 cones, right? Inner and the outer. So you're gonna find out the top part or the tip of the inner cone or the bottom, which one is the hottest, which one is the coolest, which one is the moderate heat. And the simulation of density. So you're gonna use this simulation to measure, to find out the density of different objects. So let's load this in the new Windows. Okay, so in this simulation, it shows you different materials and it helps you to calculate the density. Remember from the lecture outline unit 1, the density is a ratio between mass over volume of that object. So if you click on the materials here, you're gonna see different type of materials. Let's try with styrofoam. So you are given the mass of the styrofoam is 0.75 kilogram, and then you're gonna put in water. In the tank of water, you're gonna see the volume of the tank water change from 100 to 105, which is mean the volume of this piece is 5 liter. So in order to calculate the density of this styrofoam, you take the mass, which is 0.75, divided by 100, 105 subtract 100, which is the volume of this piece of this styrofoam block. So it's gonna be 5 liter. 0.75 kilogram divided by 5 liter, then it's gonna give you the density of this styrofoam, which is 0.15 kilogram per liter. So remember, density is the measurement of mass over volume. So the units of density will include 2 different units of mass over units of volume, which is liter. So density is always have 2 different type of units. So density is always kilogram per liter or gram per milliliters. And kilogram is one of the units of mass, and liter is the basic units of volume. So you can adjust the volume of the piece of the material, so you can adjust it. As you can see, as you increase the volume, the mass is also increased. If you increase or decrease the size of any materials, you're gonna see the density is none change. So the density is the constant number. Doesn't matter how big or how small is your piece of materials. Okay, so if I increase the volume, make the piece bigger, increase the volume, the mass is also increased, which is the density stay constant. Same thing with different type of materials. Let's say aluminum. Aluminum, so I make it smaller piece. It's calculated for you already. Aluminum have a density of 2.7. So if you have 12.78 kilogram, I put it in water, it's gonna sink, and it's gonna change the volume of the tank from 100 to 104.74. So the difference between before and after of the tank volume is gonna be the volume of this aluminum piece. So you take 12.78, which is the mass of aluminum, divided by the volume, which is 4.73, you will get the density of aluminum is 2.7 kilogram per liter. So basically, if I adjust the size of this aluminum piece, you're gonna see the volume increase, the mass also increase, which is make the density stay constant. It doesn't depend on the size of the materials. Okay, you can try different type of bridge or different type of materials. So when you try this, make sure you you do the split screen to answer your lab assignment at the same time. Okay, so which material is zinc? So you're gonna try all of these 5 materials from styrofoam to aluminum. You're gonna drop it in the tank of water, and you're gonna decide, you're gonna write out which one is zinc, which one is floating on the water. For example, styrofoam is supposed to float, right? So you're gonna write out it's gonna be float in water. Which material float? So try 5 of them and then answer these questions. And what do you think the label mass means? So what did mass mean? Mass tell you how heavy your material is, right? And okay. So what properties of the block can you change? So you can change the mass, and you also can change the volume, right? Density is stay constant, right? Doesn't matter how big or how small the piece, the object you have. Okay, so Joy does adjust that simulation to complete this as this answer. To create a block with very low density, and then you also create a block with high density. So something with low density, what does that mean? Which just mean it has very large volume per very minimal amount of mass, right? So it's gonna give you the low number in density. So adjust that. So let's try. I can design my block with very low density. So how gonna do this? I'm gonna adjust the mass very low number, and it have very big volume, very huge piece, big in size, but the mass is very little. So I only have 1 kilogram per 10 liter. If I put it in, it totally float on top, right? So the density of this piece is going to be 0.1 kilogram per liter. So density is very low. According to this simulation, as you can tell, the higher the density, is your block is going to be sink. The lower the density, your block most of the time is going to be float. So if you create something very high density, what you're going to do? You're going to have maximum mass and very little piece. So small inside but very heavy. It takes very little space, but it's very heavy. So as you can see, I can adjust the mass all the way to the max, and I can adjust the volume all the way to very minimum, right? So it's gonna be sink immediately. So this piece have the density 10.0 kilogram per liter. So you can compare that. This piece, this block I just designed have very high density. So very high density, it's gonna sink. Very low density, most of the time it will float. Okay. So the last problem you need to do, you have 3 blocks according to this picture, A, B, C, and you're gonna see the way it's floating and sink differently. So what it tell you, the 3 pieces have the same size, but they float differently, which is it tell you the 3 pieces make from what different materials, and which one have the highest density. So which one is the sink to the bottom, it's gonna have the higher density, which when you compare A and C, which one less floated? So this one is sink more than A, so C should have higher density, and A should be the one with very lowest density. Okay, so if you based on this scale, you're gonna see density of water is equal 1.0. So any material with very low density, lower than 1, most of the time it's gonna float in water. Any materials you have designed or you have seen have density greater than 1, most of the time it's gonna be sink in waters. Calculate density. So we can figure out density of block using division. So you know the density is a ratio between mass and volume. So let's get back to the simulation. You have 5 different blocks, A, B, C, D, E. So you're gonna finish this 5 block, and then you're gonna figure out its density, and you're gonna calculate this density. So how you gonna calculate density? You know the equation of density is mass per volume. So let's try with A first. So how we gonna know this mass? So there is a balance for you over here. Let's put it in. So if I put this block A on top of balance, the mass is 65.14 kilogram. Now I'm gonna measure its volume. So I'm gonna drop it in water. Initially, the tank I have is 100 liter even, so I drop it in. Now the tank is increased by 103.38 liters. So the difference between before and after, which is 3.38 liter, is the volume of block A. And the block A have mass of 65.14. So mass divided by volume. So I take 65.14 kilogram divided by what? 3.38, which is the density of this piece. So you're gonna repeat the same technique with piece B. So you're gonna measure the mass 0.64 divided by volume, which is, what is it? Put it all the way to the bottom, 1 exactly. So 0.64 kilogram divided by 1 liter gonna give you the density of block B. And you're gonna complete C, D, and E. Record the mass, record the volume, record the density, and based on your observation, is it sink or float. And try to make sense that if the density you calculated is lower than 1, it's supposed to what? It's supposed to float. If the density you calculate of the object higher than 1, that material is supposed to what? Supposed to sink. So make sure you're gonna see the correlation between your prediction and from your simulations. And the last part, you're gonna measure the density of the pennies. Pennies is made up of mixture between copper and zinc. And copper and zinc have different density. Copper is heavier, copper have higher density than zinc. So the mixtures of copper and zinc should have a density in between density of zinc and density of copper. So the density of the pennies you're gonna calculate is gonna be any number between 7.14 to 8.92, because pennies is a mixture between a percent of copper mixed with a percent of zinc. The reason they make the penny with a mixture of copper and zinc because zinc is a lot of cheaper than copper. So to reduce the cost of making the penny, they're gonna mix more zinc into the copper to make the pennies. So you're gonna find 20 different pennies. You're gonna measure the mass of 20 different pennies, and then you're gonna measure its volume and divide the mass by the volume. You're gonna get the density. And doesn't matter how many pennies you have, the density should be what? The density of pennies should supposed to be a constant number, which means it no change. Doesn't matter how many pieces of pennies you have. Remember, if you adjust the size of any materials, you reduce the size, the mass is also reduced, which is the ratio between the mass and volume is gonna stay constant. So when you're calculating, you're gonna see the density of 5 penny or density of 10 penny or density of 20 pennies to calculate. This number is supposed to be very close to each other. Alright, So at the end, make sure you recap what you have just learned. You need to be able to identify what is the beaker look like by watching the first video, what is the beaker tongues, what is the test tubes look like, what is the evaporating dish. You're gonna see the picture on your lab quiz and make sure you know its identities. What is the graded cylinder, alarmier flash, test tube holder, and funnel. You know how to read the measure of solid and liquid surface. Be able to describe how to repair, how to light a Bunsen burner. Basically, you're gonna describe which part is the hottest or the coolest part of the Bunsen burner flame. And make sure you be able to how to calculate unknown substance, how to calculate the density of unknown substance. Given the mass and the volume, you're gonna be able to calculate the density of any unknown substance we're gonna given in your lab quiz. So make sure you review this. It's absolutely gonna show in your Exp01 lab quiz. If you have any question, just email me.